Hi and welcome to another live event directly streamed from our Technology Center in Schramberg, Germany. My name is Michael Deditsky. I'm the Technical Managing Director of SolidCamp Germany. First of all, I would like to mention that we have all been tested negative for Corona. Today we have invited two really interesting partners, Citizen and ISCAR, and we are going to showcase how the interaction between machine, tool and CAM can help to machine even complex parts on Swiss-type machines. First of all, Citizen is going to talk about the news. Mr. Adrien Travesi is the European Sales Manager. And after that, Mr. Jonas von Kalden, who is a product specialist for turning tools at ISCAR, is going to talk about the news on the ISCAR side and, of course, the tools we have used to machine the bone spoon. Adrien, will you take over?
Yes. Thank you, Michael, for the lovely introduction. In the name of Citizen Machinery Europe, I welcome you to our live webinar at SolidCamp in the Black Forest area. We have different news from Citizen Machinery Europe. We have new Swiss-type machines, we have new fixed-head machines and new technologies, which I want to introduce to you in the next 15 minutes. I will start my presentation. I will start it with the workpiece which we realized together with the SolidCamp and with ISCAR on our D25 machine. This is a Swiss-type machine which meet all the characteristics of a Citizen machine, starting by the quality and the precision, going to the user-friendly and flexibility of this Swiss-type machine. The machine is very high productive in point of view cycle time, and the key point of the D25 is the milling performance. The machine can handle simultaneous 5 axes. This gives opportunity to making very complex parts with a very complex shape by milling with interpolation of 5 axes. Then we have the newest Mitsubishi controller, Meldas 850, installed on the machine, and we have our unique LV technology on both spindle, in the main and in the back spindle. We introduced a few years ago here at SolidCamp the LV technology to our customers and to our SolidCamp customers. And just for you, maybe you don't know the technology yet, if you are working with difficult material and you have nasty ships in the work area, you can use easily the LV technology to break the ships and to increase your productivity. We will see this technology also in the next 2 machines, and then I will give you also more information. Going to the kinematic of the machine, we have in total 12 axes, 9 linear axes plus the B servo axis, servo programming axis, the B1, and we have the 2 rotating axes on main and back spindle. The machine has 3 lines for programming. In blue color is mentioned the interpolation between main spindle and the gang tool post number 1. In orange color is the gang tool post number 2. By the way, the gang tool post number 2 has also an individual Z-axis, which allow us to machine with 2 tooling simultaneous with a different cutting speed. Then in green color, the back machining, the back spindle with the additional 3rd Y-axis, Y3, which allow us to make also in the back side complex machining which, and to reduce, of course, the cycle time and to take some operation from front to the back side. So the machine with 12 axes is, of course, a complex machine with 3 lines for programming. But in this point, I want to mention that the machine is prepared with a smart software behind for programming check. So the operator can really use step by step the line 1, then the line 2 and 3 to build step by step the program. The machine is prepared with a program check without moving the axis. The machine will detect interference and detect alarms or writing mistakes. And also very important, thanks to the SolidCamp software, we can prepare all the program externally on the PC, we can have a simulation, and then we can import it to the machine side. So a lot of features with making the operator stressless by setting up a new program. Going now, before to forget, the sliding headstock D25 is developed for Europe. This is a demand which have many years ago our customer asking for a Citizen machine with a double gang tool with more power. So the machine is here ready and we install it in Europe. Many of the D25, for example, in the job shop sector, the machine need to be flexible and fast. So the D25 is fast, first due to the new controller, Meldas 850. The communication of the processing time for reading program or PLC is 3 times faster comparing to the old Mitsubishi Melda 700. And also the communication between NC and amplifiers is 3 times faster. So this will help us to reduce idle time. Then we have also the Streamline Control. This is the macro programming behind, which the operator cannot see, but this is affecting the tool change, is affecting the spindle acceleration, deceleration, and this can reduce also the idle time to 20%. Making the machine flexible is of course a number of tooling possible. In the D25 we can install 59 tools in total, which making the machine attractive for the job shop, of course. Then going to the medical sector, the machine has the high-end technology installed. We start with the B-axis. The B-axis has an angle, adjustable angle by servo motor 135 degrees with 8 tool positions, 4 in the front, 4 in the back. Then we have the high milling performance. We discuss about the 5-axis interpolation is possible on this machine to have the super finishing. And we have the LFV technology, which we discuss about. In the medical, we have the titanium material, we have stainless material, which are producing very long ships, and we can thank the technology, LFV technology, really get the ships very small and increase the productivity. So, going now to the power of the machine, the D25 is also focused on the automotive sector and aviation sector. We increase the power comparing to a standard 20mm machine to 50% more. In the main spindle we have 50% more power, in the back spindle, and also in the rotary tool on the gang tool post. Then the cutting performance, thanks the double linear gang tool post, we can impose with 2 tooling, and means we can turn from 20mm down to 10mm in one go. This reduces cycle time, and for that we need a rigid machine. We need a rigid casting of the machine. So the machine has in total 3.5 tons to absorb vibration and to keep a stable precision during the cutting process. Then all this technology, all this 12 axis and all this possibility are really designed in very compact machine. The footprint is just 3.3 square meter. The machine has a length of 2.5 roughly, and a largeness of 1.4. Going now to our next Swiss type machine, Citizen Syncom L20E ATC. The L20E ATC meet also all the characteristics what we have in our bestseller L20. So the machine has a bar capacity of 20. Optional, we can increase to 25. Then we have 2 Y-axis, also 1 Y-axis to the back machining for complex milling on the back side. Then we have the LFV technology on both spindles. Then we have the B-axis servo motor, same like in the D25, what we see, the servo with 135 degrees. And here we will see also the benefit of the new technology, the ATC. ATC means automatic tool change system. Here some picture showing the B-axis with 2 rotary tools. The lower tool position will be exchanged automatically during the process. I will simulate here some pictures. Now we are going to the magazine for changing the tooling. We have a magazine with 12 tool position. So we have 12 tools available to adapt to the B-axis. So here we are changing and coming back. So this of course will give another opportunity of machining of complex parts in the automatic modus. This is also a machine which is very attractive, of course, to use with the SolidCam software. The SolidCam software will be very nice to program very complex parts with this B-axis. The machine can, by the way, also handle 5 axes simultaneously. So this is a short introduction about the L20 ATC. Now coming to the fixed head machine from Citizen. We call it Miano. Miano is a Citizen fixed head machine. In this presentation, I will show you a 42mm machine on both spindle, a bar capacity of 42mm. The machine has 2 turrets with each 12 tooling station. In total, we have 24, but we can easily increase by using double or triple holders on the turret side. Then also important to know that we have 2 Y-axes on each turret. We have back spindle with a very long x-axis. We will see it also in the kinematic. And we have main and back spindle with the built-in motor technology. And the first new, the LV technology installed on both turrets. Having a look on the machine outside and also in the work area, the ANX42 SYY has on the left side, you can see the main spindle and the upper turret and the lower turret. And from the right side, we have the back spindle and the part catcher system. By the way, the controller is here FANOC 31, also a famous controller which is easy to handle with the newest technology of the touchscreen panel. Having a look on the kinematic, 2 turrets, as I mentioned, with the y-axis means we have in total here 8 axes. Yeah. For the 2 y-axis, the benefit is of course to reduce the cycle time by using this superimposed by milling together with turret 1 and 2, and giving also more stability during the milling process. Also important to mention that both turret has a very long z-axis that we can achieve with the both turret, also the back spindle. So we can work with both turrets also in the back spindle simultaneously. And thanks to the long x-axis, in total 240 millimeter, means from the 0 I can go up 120 millimeter. I can go down with the back spindle 120 millimeter to the lower turret. This gives the possibility, for example, to use the superimpose with 3 tools together. It looks very complex. You can see in the picture here. By the way, in YouTube you can see also different videos about the ANX. The superimpose, it looks complex, but for the operator, he has really to program his machining between turret 1 and main spindle, and then separately he will program with the same tool position to the back spindle. At the end, he gives a G-code, and the machine will make simultaneously this machining. Thanks to the x-axis, back spindle can follow the main spindle. And we can, of course, add the tool number 3. Like this, we can reduce the cycle time, and we have a very flexible machine. Also to share some machining parts from the main spindle to the back spindle. So if you want to learn more about the LV technology, how it works, what are the benefits of LV, if you want to know more about the ANX or about our Swiss type machine, just please contact us via webinar at cme.citizen.de, and we will make for you a special webinar to discuss your productivity, your workpiece. So that was about our new ANX Miano machine. Going now to a special technology which we are following since many years. It started as a prestige project, laser integration on our turning lathe. The benefit is that we can include in the turning process laser cutting instead of milling, means cutting of with a very small radius of roughly 10 micron with a laser, which is with milling tool nearly not possible to do. Welding different materials, for example, ferro and magnetic and non-magnetic materials, welding on the machine and then turning in the same process. Also, the surface hardening with the laser is possible. For example, you imagine you are producing a shaft, and after turning process, you make hardening for the seat for the bearing. So in one process, you can have hardening plus turning. So in the last years, as I mentioned, we was really investigating with the laser technology, and at the moment I can introduce you that the laser is in our L20 product since 2016. The laser integration was done in 2018 on our A20 machines, Swiss type, and also 2019, especially for an automotive customer, we produced the laser on the L32 machine. It's also a Swiss type machine with 32 millimeter capacity. And last year we make on a small L12 machine also the laser integration for a medical customer. What we are doing now, the laser integration in the turret of a BNE 51 MYY. This is also a new fixed head machine, and will be very nice to have also a laser integrated. So when we are ready with this machine, we will of course inform you. So of course, laser technology, if you need more information, maybe you have some products where you think that the laser can be helpful, just contact us please, and we will arrange a webinar together with you, with our engineer, we can discuss it. Going now to the next point, this is also information that CME, Citizen Machinery Europe, are producing handling system by ourselves, individual solutions for our fixed head machine, sometimes also for the Swiss type, for the low budget, and we can meet a flexible demand of customers with our own development department. So Smart Factory Industry 4.0 is an old topic, but is always coming more and more. This request from our customers: are the machines, Citizen machine, ready? Yes, the machines are ready. The machine has installed the network function, and the software is also ready to integrate the machine to the Smart Factory. So we have two kind of communication. The OPC-OR. This is manufacturer independent data exchange to connect the machine, or the MT connect to observe your machine, to observe your productivity, and to make analysis after that. Some examples here. We have the human-machine interface, simply and intuitive. Here's example, like you can monitor your machine. In this case, this is spindle monitoring. You can see the load of the spindle, the temperature of the spindle. You can observe also the RPMs. So if the machine is getting, after many years, problem with the bearing, you can see here that something is getting over the limit, and you can contact the service. It means you can also make some preventive maintenance in advance. Point of view productivity, with many of our customers are using. You can have observation of the productivity on your machines. It means how many hours did you produce in the first shift, in the second or third shift, how many good parts was produced, how many bad parts are produced, how long is the machine running, how long is the machine in alarm status. This gives you a good overview to improve your productivity in the future. So also old machines we can adapt with this software. Coming now to our last point, what we are also doing parallel to improve the communication with our customers. So we have a Citizen app for our end users. The benefit is that our end user will get information about events, like webinar from today, or about new machines via the app. They are always up to date. They can have access to our products, means technical informations, videos about our Syncom and Miano machines. The customers can have access to different videos of technologies, for example, eccentric turning or superimpose functions. You can also find here a lot of videos, useful videos. Also important to know that with the app you can also have access after your registration to buy parts online, also on the weekend. Will be very helpful to reduce time by the part delivery. And also from the service side, the app allows also the operator to have some tutorials, some videos ready, how to set the guide bush, some basic things, some basic questions what the operator maybe have. And also, if some problem happens, there is a possibility to use the app to upload videos and pictures to Citizen service, and also to call directly via the app the service and to get in communication. So I will say that was my presentation. Citizen Machinery Europe is available for you. If you have any questions or you want to see more, many ways to contact us. So Michael, my presentation is finished, so it's your turn.
Adlen, thank you very much for this really interesting presentation about Citizen. Next, as announced, Jonas von Kalden from ISCAR is going to talk about the news on the side of ISCAR and of course the tools that have been used to manufacture the part today. Jonas?
Thank you, Michael, and also thank you, Adlen, for this very
Jonas, this is for you.
Presentation.
Okay.
Thanks a lot. All right. My name is Jonas von Kalden. I'm responsible for turning products at ISCAR Germany. And we are now talking about Swiss-type machining of complex components made easy. Where we are, ISCAR Germany is located in the southern part of Germany, which is 10 kilometers south of Karlsruhe. And at the picture you can see also a nice overview of our tech center. On the right side you see the Hermle milling machine. And on the middle position, you see the Gildemeister CTX Beta 800 linear. And on the left side, you see our new Hanwha Swiss type machine with high pressure coolant and barb loader. Yeah, what are we doing? We are doing everything for the machining tools. We are doing drills. We are doing turning products. We are doing threading products, milling products, whatever you can imagine in this case. And we are also very familiar with some with industries, for example, the automotive industry, the miniature industry, and also the medical industry. And we have also special solutions for those industries. So yeah, we are familiar with these industries, and I think we can you can learn a lot from our technology in this case. Yeah. Yeah. Before we start, we have to think about why do we need special tools for Swiss type machines? Why can't we use regular tools from regular lathe? And why do we and what recommendation what demands do we have here? We have to look on the demand of the Swiss type tools. The first of all is the user-friendly. Those who have already worked on such machines, they know that the space is very small and you are working with oil. This means everything is slippery. And in addition, you have sharp cutting edges, sharp drills, sharp milling tools, whatever you can imagine. And this needs a lot of, let's say, improvements in the tools itself. And therefore, we designed also a very nice new tool, which is called Swiss Grip. The Swiss Grip tool is a parting off and a grooving tool with cutting width of 0.6 to 1.2 millimeters. I have here an example of those tools. You can see it very good. This has a blade right here, and in front is there is the insert clamped, and you can put it out with a special tool. Change the insert outside the machine, put it in back into the tool, and clamp it with the tool, of course. And then you can start the machining without correction of the x-axis. Yeah. Why do we have such a tool? First of all, we have such a tool for the reduction of the cutting force, of course, and also to save materials. Because compared to a 2 millimeters width of an parting off insert, you save a lot when you use a 0.6 or 0.8 millimeter cutting width. Another demand we have in the market is the sharp cutting edge. We see that the market needs more sharper cutting edges compared to our standard portfolio. And why? This is the question. The question is why do we have such sharp tools, sharp cutting edges in program? First of all, you have to look on a CNMG, which is a negative pressed insert. And if you are machining a 42 CRM04 material with a feed rate of 0.2 and the cutting depth of 2 millimeters and the lead angle of 95 degrees, you have a passive force of 346 Newton. This is the passive force is mainly cause some material and dimension deviation in the process. And compared to a CCMT, which is the positive pressed insert, you have only 280 Newton. And compared to a more sharper, which means is a positive grinded version, you have 240 Newton. And a lot of our customers contact us and ask us, how can we get more process stability, and how do we get more sharper cutting edge? So we start to think about a new grinding process. This means we created a completely new grinding process, and then we reached a passive force of 200 Newton, which is nearly 20% less cutting force compared to a regular grinded insert. Why do we need this? We need this for especially on small diameter where we have a lot of deviation in this case. Yeah. Here's a picture of such a cutting edge. This cutting edge is only available as special because we have to check the complete process in the machining, and also we have to check the material and to figure out if it's possible to make also coating, etc. Another point which is very common, especially at the regular lathe machining, for example our CTX machine, is the rigidness. Rigidness means that we have a stable tool which is rigid clamped in the holder. And here on the picture you see our pico line. Our pico line, the one on the top is the old pico line, and the one on the bottom is the new pico line. And I have also both versions here on my table. And you see very good that the clamping length increased by 30%. So this means this is the old pico line and this is the new pico line. And why is the question? The question is because of the rigidness of the tool. If we are more stable in the process, then we have higher tool life and we have better surface quality and we have a higher process stability, of course. And this system, you see it also here, this is a hand clamped system. I will demonstrate it for you. You can declamp the tool by fingers, by hand, and you can replace the insert or change the insert, and you can clamp it by hand. This is enough for 90% in every case. We recommend to use an additional wrench to increase additional clamping force when you're using high pressure. This means pressures, oil and coolant pressures over 100 bar, for example, and also by back turning operation. And we also equip this tool with 2 additional coolant outlets to increase the tool life and to prevent chip sticking inside the hole. The other point is the versatility of the tool. What do I mean? I mean, I have one system that can do a parting off, a grooving, a groove turn operation, that can do a threading operation, etc., etc. And here we have created a complete new tool which is called Panda 17. Panda 17, you see it here. Panda comes from the 5 cutting edges. The name Panda comes from the 5 cutting edges. And this is also an all-rounder tool. Why all-rounder? Because you can do here a back turning operation, you can do here a groove turn operation, a full radius grooving, thread grooving, parting off, and also grooving operation. This means if you have your gang blade completely equipped with this tool, you can only change the insert, for example, from a thread turn insert to a groove turn insert, and you don't have to do any corrections in the machine offset. And the other point, I better say it's the friend of every machinist, is the repeatability. Because no one of us wants to spend many workpieces and time to check the offset after a tool change, to get the dimensions, of course. And therefore, we decided to put all the tools with a very narrow tolerance, for example, of our tools by 0.01 millimeters. And the biggest guideline of our products is the KISS principle, the keep it strictly simple. What do I mean with this? I will demonstrate it to you by our completely new tool, which is called the exchangeable head system. If we have equipped our complete gang blade with one tool, for example this tool, and we can only easily change the head of such a tool, and for example put in a Swiss card or a Panda system like we seen before, then it's very easy to get a complete different application for this without changing the complete tool. And another side effect for this tool is that it has a vibration damping effect compared to a regular monoblock tool, for example. Yeah, this we will launch in 1 to 2 months, and then it will be available for the parting off. It will be available for the grooving, groove turn, threading, Isotron, of course, for the complete range. And then you can use all the system in one machine. Another point, or my last point, is the new ETA Tool Advisor, which was updated also because of the corona or pandemic situation, which allows now our customer to easily get the correct tool for each application. You can find it on our website. It's called ETA. And you can also select the correct language, of course. For example, United States. And then you can dial in the correct machine. We have different machine types. And you can also save your own machine with the shank size, the power, and etc. Yeah, and then you can press the select button. And then you can select the material. In this case, it's the 1213 material, which is very common for the Swiss type. And here you can check the application. What do we want to do? In this case, we would like to make an outside grooving. Select grooving outside, and then put in all the dimensions, for example, the cutting width and the cutting depth, etc. And at the end, you get a complete overview of our tools, of the dimensions of the tools. You get the cutting speed recommendation, and you get also a package of step files that you can use at the new SolidCAM version. Yeah, that's it from my side. Thank you.
Jonas, thank you very much. That was a really interesting insight about ISCAR. So we have talked about machines, we have talked about tools. Of course, the CAM part is missing. Our Markus Ritter, who is our specialist for mill turn and especially for Swiss type, is going to talk about how easy it is to program also highly complex parts on Swiss type machines in SolidCAM. Markus, are you ready?
Yes, great. I am. Okay, the cable. So hello and welcome from my side. My name is Markus Ritter, and in the next 15 to 20 minutes I want to show you how easy it is to program such a part, what we can see here, like a medical part, a spoon with a rasp here on the other side, how easy it is to program such a part with SolidCAM. Due to the time window that we have available, this part is already programmed. So I will guide you through all the stuff what we have here in SolidCAM. First of all, we had our setup where we can define and also visualize the part position in the main spindle. We have here 250 millimeter stroke on the Z1 axis. Here for the Z1 axis we need approximately 150 millimeters to machine the part. And on the back spindle we had defined 20 millimeter projection length out of the sub-spindle here. This will be used later for the part pickup. Yeah, then let me open our new toolkit, which is introduced with SolidCAM 2021. We can define and also we can see here some ISCAR Pico turning tools, full 3D models for ID turning, ID grooving, ID threading operations. We have here also a small boring bar, 4 millimeter in diameter, with its related insert, also full 3D model. We had for this part a multi-master engraving tool here, and also for the turning operations V-shaped insert turning tool, also full 3D model. And on the B-axis we have also another multi-master tool for face milling, also full 3D model. And let's mention this tool also, another multi-master milling tool with indexable inserts, 8 millimeter in diameter, so really small. The best or a new option in SolidCAM, especially for Swiss type machining, is here for turning jobs, break material corner on stock. Let me simulate this. Here we can say we can define a size and an angle to break the material corner, especially for Swiss type machines, very useful. Sometimes you will get a burr here, and if we retract the bar into the guide bush, then this burr will be pushed away, and this is not so good for the carbide of the guide bush. So therefore we have here this option to break this corner and remove this burr, especially for Swiss type machines. Then of course we can also use balanced rough operation. Here we have selected balance mode synchronous with a distance of 1.5 millimeter and 0.2 millimeter for the slave tool. We can see it here, the master tool, and the slave tool is here above the master tool and in front of the master tool. And we can also use balanced rough operation on the D25 here, because we have two tools. Then we had some regular turning operations here, also another balanced rough operation. So we divided this portion here of the part into two sections. We don't want to retract the bar or pull the bar out of the guide bush. We have some 2.5D milling operations here to flatten these areas here from the spoon side and also from the rasp side. And then we had here our program rasp section. So, and what I can show you here is how easy it is to select the geometry and program this. So we have here a 2.5D profile operation. In the geometry page we can say new, and then we select the curve and the next curve and the next curve and so on. But this is very time consuming. We can also use the option add selected element, which is bind to the hotkey F6, and therefore we can select all these curves just by clicking the start curve and then go through them with F6. So we don't need sketches or something like that. And after we selected all that, we can go to we select our tool, of course, 3 millimeter end mill. We have here variable levels now, and there is no need to select all the depth for all these chains. We can just do a right click and say auto detect for all, and all depth will be detected automatically. And we say OK and save and calculate, and we had our tool paths. So this geometry is symmetrical here, so there is no need to make an additional operation and select the other curves here. We just can say here in SolidCam we use the mirror function, and we can mirror this operation, mirror about a selected plane, select the plane here, it's the right plane, mirror it about the right plane, and then SolidCam will copy the job, mirror the toolpath, and we get here our desired toolpath. And of course we can also use in mill turn, and also for Swiss type machine we can use every milling operation what is available inside SolidCam, 2.5D, 3D operation. So we can see here we have a 3D eye machining operation here. The geometry is our complete target. The working area is restricted to this spoon area here. So we just want to machine this spoon area. And in the eye machining wizard, we can choose our machining level. And if we calculate the operation, then we get our roughing tool path. We have also here another 3D milling operation, HSR milling operation for the rest material or the remaining stock, where the 3mm end mill from 3D eye machining for the areas where the tool cannot go inside. So for that we use an HSR operation, and for finishing this spoon area we are using an HSS operation technology parallel to curves. Our geometry, our drive surfaces are the surfaces inside from the spoon here, and our edge curve is here, our edge curve here on the top. And under the toolpath parameters we have a maximum step over of 0.7 mm, and for sorting the cutting method we use spiral. So if we simulate this in our SolidCam simulator, then we can see that we're starting in the inside and going with a spiral toolpath from the inside to the outside to finish this portion of the part. Then after all that milling, we have here two independent turning operation. The first operation we perform a single semi-finishing cut, and the second operation will do the finishing cut on this part of the on this section of the part here. And these two operations will then be later synchronized with each other in the channel synchronization. For the faces here, we are using a profile operation, just a straight line to get the best, the shortest machining time. We have just one single line, down, up, one finishing cut, and then the next. And then we transformed it around because there's no need to make 3 jobs for each phase. We can just make one operation here, and then we say, okay, transform this operation around the 4th axis 2 additional times. And what's also worth to mention is here how easy it is in SolidCam if you have such engraving stuff here on the part. You can use the 2D engraving, and it's very easy to select the geometry here. Even if it's wrapped on the part, you just say new, choose geometry type, wrapped. The geometry is wrapped around the Z-axis. As we can see here, it's wrapped around the Z-axis, and then we choose multi-chain, and instead of selecting all the curves, we just click into the faces here and the E. Say OK, and SolidCam will generate all the chains for the specific faces here. Yeah, and of course the selection of such geometry is also for the other engravings also easy. Then we come to the part transfer. Here we have our machine control operations, technologies. There are several predefined technologies. For instance, pre-positioning for part cutoff here. We can also visualize it in the machine preview. Here we have our Z position for the cutoff, for the pre-positioning. We can input it, we can select it from the model. We have an additional MCO machine control operation for the part pickup with a sub-spindle. Here, pre-positioning 50 millimeter in front of the part, and then go to our part pickup position. If we look from underneath the machine, we have here our setup location, which we what is defined in the setup, our 20 millimeters. Yeah, then we had our cutoff here, and also on the back spindle some small operations. If you simulate this here, just drilling, and then with the ISCAR pico tools, a little bit of turning and then threading. Yeah, and after we had programmed all the whole part, we can go into our channel synchronization here. And here we see we have a 3-channel machine. So the Citizen D25 is a 3-channel machine. We can synchronize here our operations. So let me show it. I just delete the synchronization, reorder it. Now we have the order of the CAM3. So this means each operation will come after the other operation. And for a nicer or a better synchronization, we can tell SolidCam, hey, with this operation for you here, starts a new machining on the back spindle. So therefore, we can move, drag and drop here these operations and say, okay, we want to do this machining, this operations, we want this in the same time as we do the operations on the main spindle. And then we synchronize these 2 independent turning operations, so we get superimposed control. We can also synchronize these two operations. We can also add manually sync labels. Say we have here the axis pattern G750 for the Citizen machine, and after that we cancel all that with G711. Yeah, and after the channel synchronization, after when we had all synchronized all our operations in the order what we want, we can simulate this also in our machine simulation. So we can start the machine simulation, and the machine simulation here in SolidCam is the only integrated simulation which will simulate the synchronized operations, or let's say the channel synchronization order will be simulated in the machine simulation. The other simulations, Solid Verify, Host Cut, Turning, will just simulate the order of the CAM3. Yeah, now machine simulation data will be prepared. This takes a little bit because all the data, all the movements, what we have in the operations will be prepared and will be sent to the machine simulation. Also the tools, the 3D data, and so on. So now you should see our machine here. Now the jobs will be loaded. And now here we see the jobs, and we were waiting for the tools. Now the tools are loaded, and now we can run our machine simulation. And we have here our a nice machine simulation with a full 3D model from Citizen. Let's hide that. We can start this the simulation. We see our turning with our drilling with the back spindle, then the turning with the Pico tools. Let me pause it and let me go forward where it's interesting, because here nothing special has happened, just a little bit turning. The interesting stuff will be done on the main spindle. So here we have face operation, then our synchronous balance rough. Let's speed that a little bit up. Finishing another synchronous balance rough. Then here comes our Multimaster 8mm end mill. The other side. Then let's pause it. We have here the milling of our rasp section with inclined B-axis. Also the mirrored operation for that. Then we have our 3D eye machining operation here simulated. And let's rotate it again to view. Then our HSR rest roughing, our HSS finishing operation here with spiral motion, and then we had our superimposed operations here. As you can see, the Z2 axis of the machine is now superimposed to the Z1 axis. Let's speed it up. Our face milling here, and then the engraving of the solid cam, and also the engraving or the cylindrical engraving here. Then Citizen, and also for the third phase, or on the third phase, the ISCAR engraving. Yeah, and after that, oopsala, that was wrong. Yeah, wrong button. I do not want to close our machine simulation. Now preparing now the jobs again. Restarting the machine simulation again. Yeah. That's live. Clicking the wrong button. So let's wait for the operations, for the tools, and then we can go forward. There is no need to start it again from the beginning. So we can go right to the cutoff. You can go right here to this operation. So there is now the verification or the calculation of the operations until this job here. This will take some time here because of the engraving stuff. Yeah, now it's a little bit faster here with all the engraving operations. We are nearly there, 80%, 90%, fast forward. So this was our last position here, and after the engraving we have here our part pickup and part cutoff. Back spindle, travel over the part, doing the cutoff. Yeah, and with that we are at the end of the presentation. We have prepared a video of the machining, and if you have any questions or need information, then don't hesitate to contact us. Thank you, and yeah, here.
Marco, thank you very much, and I think we all have seen that it's live, so sometimes things happen. So Marcus, please start the recording. Jonas and Adlan, feel free to talk about the tool and the machines in this video. Stage is yours.
Thank you. Jonas, you start.
Yeah, you see the first application, which is the Isotron application. Here you can see a chip former, which is actually developed only for the medical industry. For example, the cobalt chrome machining, and also high alloyed stainless steels.
Yeah, we can see here now the superimpose turning with two tools together. So at the moment only one, but in the same position we are using the same feed rate on both gang tool posts, but we will have a good example when using the second Z-axis of the gang tool number 2 to machine with two different feed rates. So we are seeing the same position. You can see that in the left side, the gang tool number 2 has also drilling process or inside turning process for the back side. Also now this is the B-axis for cross machining or cross milling. We can also use the B-axis for the back machining.
On the back side, you see also the Pico Ace in action. You see the threading operation now.
So we have on the back side possibility to integrate rotary tools or fixed tooling for turning and milling, thanks to the Y-axis on the back side. Yeah. Maybe in this stage also important to mention that we are working now the machine as a Swiss type with a guide bush. We can see the material is sliding. We can also modify the D25 to a fixed head. It means we will take the guide bush out and work with the main spindle directly in the work area. The benefits basically two, we can reduce the remnant part. It means this is also money. If you are producing from expensive material, you can reduce the rest of the bar to the minimum. And the next benefit is you can use material with less quality, with H11 for example. Okay, this is now cross machining from the gang tool post number 2. So now the B-axis for the finishing, right? I think this is the tool for the finishing now.
The ball nose, ball nose tool, ball nose milling tool. And after that, we should see the engraving. Oh no, it's the simultaneous
turning with two different cutting condition, let's say. Now this is the benefit of the Z-axis. We can also use it by milling in different positions. We can use it now as turning with different feed rates. We have really 60 millimeter on the second gang tool post, and this makes the machine very, very flexible.
Here you can see also a multi-master milling system. Multi-master is a modular system that allows you to clamp only one shaft one shaft, and put on the head different milling tools or drilling tools or engraving tools.
In general, about D25, we have two types of D25, type 7 and 8. What we have now is type 8 with the servo controlled B-axis, and this is only different to type 7. Type 7, we will have cross-rotary tools on the gang tool post 1 instead of the B-axis. Yeah, but type 8 is a high-end category in the D25 sector. And also maybe interesting to know that we have also a kit to increase the bar capacity to 32 millimeter. We can exchange the chuck sleeve and nut on the main spindle, back spindle, and the guide bush from 25 to 32.
Here you can see also the engraving operation with the multi-master tool. And after that, the parting off application with a special design tool for the Swiss type machining that allows you to unclamp and clamp the insert without changing the complete tool.
So, cycle end.
Perfect. Adlen, Jonas, thank you very much for joining us today. It was an absolute pleasure.
Thank you very much.
Thank you.
Welcome. So I think it became more clear that even a complex machine can control easily with the right tool and the right software. I wish all of you enjoyed it and all of you have a successful day. Stay healthy and bye.
Thank you very much. Bye.
Thank you. Bye-bye.